Howdy everybody, and welcome to another video brought to you by me, Jack, from VintageElectronicsGeek.com. In today's episode, we're going to take a peek at this DataVideo DAC-200. And you're probably asking yourself, what is it? Why, it's one of these devices right here. Most of you are probably familiar with this. This allows you to plug in your VCR, DVD player, or vintage camera device into your computer. This item is a more of a professional item over the diamond, and so this is the last device in my analog capturing network that goes from all those devices I mentioned into the computer. So a real quick look around the face here. We have our inputs, audio, video, S, and then we have 16-bit or 12-bit, and this is for audio. And then digital video or analog video. And digital video is done through the FireWire port. On the top we toggle between digital video or the analog video as well as 16-bit, 14-bit audio. On the back we have our outputs. So these outputs we could plug into a monitor or another device, camera, VCR, etc. Dip switches here to program the device. Outside of the dip switches, this is a dumbed down device. There's no other way to program or configure it. Then on the back we have another FireWire port, and this port I actually run to my computer, and via this port is how I capture video through my NLE or nonlinear editor or video editor. It's all one and the same. And then we have our input jack for our power and our on-off switch. Nothing else. Vent holes. That's about it. The reason why we're going to take a peek at this today and see what we could do to it, or I should say the complaint about it, is this. I've been using this for quite some time. This is from the year 2001. It's been a fantastic device up until here recently. When I go to power it on, the lights up here will start to flash, and hopefully we can capture that on video today. I'm pretty confident we will, as it does it often. About 2 weeks ago or so I did tear this apart, and there is no video of this. It's one of those things I thought I'd just get a little nosy and inspect it, and next thing you know I'm knee-deep into resoldering a couple of capacitors, so no video. That appeared to fix the issue at that moment, but then we started going back into the same issue. So I'm thinking, since it is as old as it is, that's all I have a problem with is capacitors. That's what I'm hoping for anyway. But we'll get in there and probe around. It does have SMD components. Hopefully it's something easy to repair. I'm not too good at SMD. If it is SMD capacitors, I do have, but there's also some headroom in here in the casing that if need be I could put conventional, traditional capacitors and should be okay, providing there's not a whole gang of them. I went ahead and took the liberty in re-angling the camera, so hopefully you'll get a better view, an aerial view of what's happening. The way we take this case apart is we have two screws down here at the bottom, and you can see that I've already breached the stickers. And take a screwdriver to remove these two screws. And you'll see my hand is conveniently in your way. And then we have two tabs. Oops, let me get you in view here. We have two tabs in here on either side that you bend to the side and you're able to pop the cap off. After messing around with this thing for several minutes, which should have been a quick and easy open, it was actually a challenge. But I did get the cover removed. And so that's what it looks like underneath the hood here. Next thing we need to do is we've got 4 screws here in these holes. We need to pull that out, and once we do that, then this whole board will come out of the rest of the chassis. And then need to remove this cover, and once we remove the cover, then we have access to the component side of the board, and then we could take it from there what we need to do. The screws that are in here are size P2, so a standard P2 screwdriver is what we need to use. Here's the top side of it out of the case, and there's the solder side. You take some needle nose and just kind of bend these, twist them to unlock them. Now you want to be careful because you can imagine that you can only do this so many times before these little things are going to end up breaking. And here's what it looks like with the cover removed. I've replaced these capacitors right here last time I was in. We're in the power supply section, and so that's why I thought that this was going to be the issue. That's why I went with them. As stated, it appeared that it worked, just temporarily. And we'll go ahead and remove those. I guess I should have plugged this into power like I was going to show you, so you could see what it was doing before I tore it apart. So let's go ahead and do that now, shall we? The power source on this device is 5 volts, 6 watts. Ohm's law tells us that that's 1.2 amps. We need to set up our power supply. I do have the power supply for this, but it's already tucked in where it belongs, so we're going to use the benchtop power supply. We want to set our power supply accordingly, so we're going to set this up to 5 volts. And then we need to set up the current, and we want to set up current limiting. We don't want to allow it to have tons of current just rush through or blow this thing up. So we're going to set it where it has the 1.2 amps. And the way how you do it on my power supply, your power supply may be different. So make sure you check out the owner's manual on yours. You just simply short the terminals out. As such, and then we make our adjustments accordingly. So we're going for 1.2, and then we break the connection, and that's it. And I'll remove those probes off of the power supply. Have a barrel connector made up for the bench with alligator leads on it, and we'll plug that in. Then we take the other end and plug it into the board as such. The lights in question are these two right up here that's going to blink. I'm going to go ahead and throw the switch. And as you see, we've got 2 solid lights, which is what it should be. I'm showing that the current we're currently drawing is 0.64 amps. And we'll give this a moment to flash. And it's been a good solid minute since I've powered this up, and so far not flashing. So let me go ahead and pause the camera. I'll wait a few, and when it starts to flash I'll bring you back in so we can see it. Here we are about 10 to 15 minutes later, and as you see, the lights are still solid, which is a good thing. That's what we want, solid lights. However, while I was waiting for the lights to blink and do what they are going to do, I started to think about the power supply. What if? What if the power supply is bad? So on my benchtop power supply, what is running this device right now, I thought, well, let's go ahead and turn down the voltage and let's see what happens. And much to my surprise, guess what happened? Here I am at 5 volts, drawing 0.64 amps. Let me turn it down. There's 4.9 volts at 0.64 amps, 4.8 volts at 0.64 amps, milliamps. I went a little too far with my fine tune, and I didn't have so I had to go by course. So here we are at 4.4 volts, 0.36 amps. And you see we lost it. So let's go ahead and turn this back up until we see something. And look at that. Flashing light. It's not quite as bright, but we're at 4.6 volts at it's flickering, so about 0.33 milliamps. Let's go ahead and bring this up. 4.6 volts at around 4.4 milliamps. It's fluctuating. And so there's the flashing lights right there is what I have been seeing for a short spell of this problem. I don't remember the time frame. Here I am at 4.7 volts at see, it's still fluctuating on the amperage. Anywhere between 0.38 to 0.48. Here we are at 4.7 volts. Still fluctuating on the amps. And here we are at 4.8 volts at 0.64 milliamps. Or 0.64 amps. Yeah, I'm at 4.7 volts, but just dropping the voltage somewhat, is just all over the place with the amperage. Let me try adjusting the amps. Yeah, I can't get the amps to lock on. So the power source, the power supply, is apparently going to be the issue. So let me pause right here. Let me dig out the wall wart, and we'll inspect it and see what happens. I have the power supply, and apparently I'm using my power supply from my Hauppauge, which is another device similar to this, just a little newer. I'm not sure what I did with the other wall wart that I have been using for this. So apparently at one point in time I was swapping around and trying to troubleshoot this. As we can see that it is 5 volts at 2 amps, and this is a switching mode power supply. We're going to plug this in here on the bench and we're going to test it, see what kind of readings I get voltage wise. I don't have anything set up to try the amperage, so we'll at least check the volts. Going through my power supply wall wart collection, which I'm sure many of us have, right? Closest thing I find to an actual true wall wart transformer is this 5 volt 1000 milliamp. Just for the heck of it, we're going to plug it in right after I put ends on it. and we'll test it and see how this device works with that. We'll also test this voltage wise. Well, so far so good. This appears to be holding steady. Oh, spoke too soon. So there we saw the lights flickering. Let's go ahead and test the output voltage. Well, the jack's in there nice and secure. I thought maybe it was loose and I bumped it. Well, as you see, we got good voltage and it's holding steady. So I guess the next thing really would be to put a load on the power supply and see what it does. For a load, I tried using this 12-volt incandescent vintage NOS bulb. Didn't draw enough amperage to do anything. I mean, it illuminated. That was about it. Next thing I grabbed that I thought would have some kind of a load to it was this motor that came out of a one of those VHS-C adapter cartridges that adapted it from VHS-C over to VHS. And as you can see, I'm getting like a pulsing sensation in the motor. When it does turn, there's a lot of torque in there. As you can see it moving my fingers about. However, as you can see right here on the microamp meter, it's not drawing any current. I had to switch over to this meter because my Syncor apparently does not have amperage on it. Something I didn't realize when I bought it. And it don't have a diode checker on it neither. So I might entertain upgrading at another date and time. Something else that's kind of interesting is when I put the meter over here on DC voltage, as you can see, it's not showing anything. However, if I put it over on AC voltage, I do get a reading. If I plug it into the Syncor, you see that here on DC voltage, I do get a reading, 5.2 volts. It's very plausible that my probe mess right here was not making a good solid connection, and that's why the other meter wasn't showing a reading. Let me try that one more time real quick. I plugged it back into the other meter. Right now I have it set to AC volts, and as you see, I'm getting a solid 0.018. Let me go ahead and switch it over to DC voltage again, securing my connection. Let's see what we get. Okay, so that's all it was. There was my probes were not properly connected. So let me I guess it really doesn't matter whether or not my probes were connected properly for my meter to read. Thing is, we saw the motor. I stand corrected on that. I got things plugged in properly. Well, sort of. As you see, the wire just barely hanging on for the positive right there. But you could hear and see the motor. It's no longer chirping. Let me try to redo my wiring so I can get a better read on this, and we'll take it from there.